Based on the chemical composition and production metal quality, as well as the specific characteristics of part geometry and the filling and feeding system, Kasandra provides real-time predictions of the internal soundness and structure of components under production. Kasandra integrates with the plant's metallurgical control system, and its configuration and operation are performed in 4 simple stages. Stage 1. Part analysis. Preliminary engineering work, using conventional design and simulation tools, identifies critical areas of the part and potential associated defects. Stage 2. Definition of manufacturing limits. Through Kasandra's configuration, analysis areas are defined by mesh sections and the selection of critical parameters. To evaluate internal soundness and structure, limits are set for key metallurgical parameters such as nodule count, eutectic temperature, solidus temperature, and final nucleation. Stage 3. Thermal analysis and manufacturing control. For each ladle, a metallurgical quality analysis is performed. Kasandra uses the thermal analysis results to generate a prediction for each part. Stage 4. Segregation of potentially defective parts. On-screen indicators inform the operator whether the prediction is acceptable or not, enabling them to validate production or implement the corresponding action plan for out-of-range results. Parts associated with negative predictions are segregated at the end of the line for final inspection, while components produced under optimal conditions do not require additional control steps.